What if we've been looking at mental health, well, all wrong? For decades, the focus has really been on treating symptoms. But today, we're going to dive into a pretty radical new framework that targets the very core of how our brain changes and adapts. So let's get right into it. It's a question that honestly is super frustrating and affects millions of people. I mean, why, after all this time and all this research, are mental disorders so incredibly hard to treat effectively? Well, at its core, the problem is that our treatments have kind of limited success because we often don't fully get the underlying causes, the etiology, as scientists would say, of these conditions. So it's like we've been treating the smoke instead of putting out the fire. And this exact limitation has pushed scientists to search for something much more fundamental in the brain. A common thread that might run through a whole bunch of these different disorders. And that common thread might just be a concept called neuroplasticity. Now, you've probably heard that term before, but today we're going to look at it in a completely new, much deeper way. It's not just some buzzword, it's basically the brain's essential superpower. So, to put it simply, it's the brain's fundamental ability to change and adapt. I mean, think about learning a new skill, like playing the guitar or trying to speak a new language. That's neuroplasticity in action, physically changing your brain's connections every single time you practice. It's this constant conversation between our brain's networks and the world around us, and it is literally how we become who we are. Okay, but here's where this new framework offers a genuinely new perspective. It suggests that plasticity isn't just one single process. Instead, it seems the brain has four distinct types, and each one operates on a completely different timescale. All right, so let's really dig into these four timescales and see how they build a complete picture of how our brain adapts, from the blink of an eye to an entire lifetime. From the instantaneous firing of neurons that create our conscious thoughts, all the way to the slow, steady shaping of our deepest personality traits over a lifetime, each of these speeds plays a unique and absolutely critical role in our mental lives. First up, at the fastest speed imaginable, we have cognizance plasticity. This is the lightning-fast process that pulls together different brain networks from moment to moment. It relies heavily on something called the central executive network. You can think of this as your brain's CEO, the part that's responsible for focus, planning, and decision-making to create your seamless conscious reality. A really great way to think about this is to imagine your brain is a super powerful computer. Well, cognizance plasticity is like its operating system, just running everything in the background. It's what allows you to solve problems, plan your next move, and just navigate the world in real time without even thinking about it. Okay, slowing down just a little bit, we get to reactive plasticity. This one operates over minutes to hours, and it acts as a short-term stabilizer. So when something stressful suddenly happens and threatens to throw that super fast system off balance, this is the system that kicks in to keep things steady. Right, so this is the system that manages your brain's immediate response to major disruptions. It's the reason you can cope with a sudden shock or a really high-pressure situation without completely falling apart. It helps your brain, hold it together. Now we're moving into a much longer time scale, weeks, with adaptive plasticity. This is where long-term learning and memory really start to take root. It's governed by this famous principle called Hebbian dynamics, which is often boiled down to the saying, neurons that fire together, wire together. It basically just means the more you use a specific pathway in your brain, the stronger that connection gets. So the really crucial point here is that this is how the brain builds its own internal map of reality. It's constantly updating this map based on your experiences, trying its best to predict what's going to happen next. And that, of course, makes you way more efficient and better adapted to your environment. And finally, spanning your entire life, we have developmental plasticity. This is the master architect of your brain. This process shapes your default mode network, which is this incredible network that's most active when your mind is at rest, when you're daydreaming, reflecting, or thinking about yourself and other people. It's really the sum total of all the other plasticities, creating this stable foundation of, well, you. Yeah, this slide just illustrates it perfectly. Our life's experiences, from when we're kids all the way through adulthood, create the very foundation of who we are. This lifelong process shapes that at-rest brain, that default mode network, which in turn defines our unique personality and our fundamental way of seeing ourselves and the world. Okay, so we have these four really elegant systems for adaptation, all working at different speeds. But what happens when they go wrong? This is where the framework connects directly to mental health, and it offers a completely new lens for diagnosis.
So this new framework lets us literally map specific failures in plasticity to distinct brain networks, and from there, to specific psychiatric conditions. I know this looks like a lot, but just as an example, if you look toward the top of the diagram, you can see how issues in that CEO network, the central executive, are linked to psychosis. It's a really powerful way to visualize the biological roots of these disorders.
And this table really simplifies that complex connection. Notice how a problem with the fastest millisecond range cognizant plasticity leads to psychosis. Now, look at the next two rows. This is super interesting. They both involve the salience network, which is our brain's detector for what's important right now. It helps us filter information. When that network has a short-term reactive plasticity issue, it can result in anxiety. But if the problem is with the longer-term adaptive plasticity, it can lead to mood disorders. And finally, lifelong issues with developmental plasticity and our default mode network can show up as personality disorders. This shows that the when of a plasticity failure is just as important as the where. So this much deeper understanding opens the door to a truly revolutionary question. If we can identify not just where, but also when plasticity is failing, could we directly target and maybe even correct these specific disturbances? And the proposed solution is this fascinating, synchronized, three-pronged attack. The idea is to use medications, like SSRIs or maybe even psychedelics, to create a state where the brain is more open to change. Then you could use direct electrical stimulation to precisely target the specific networks that need help. And finally, immersive virtual reality could guide the brain through new experiences, actively helping to rewire it in a healthier, more adaptive way. It's a whole package. The vision really comes together in something that looks like this: a futuristic, integrated headset. And it wouldn't just deliver treatment. It would first diagnose a person's mental state by sensing brain activity, speech patterns, even facial expressions. Then, some kind of algorithm would translate all that data into a personalized, combined therapy delivered directly and totally non-invasively. This quote from the framework's author, Dr. Abraham Pled, just perfectly captures the core idea. The future treatment in psychiatry will be achieved via modulating plasticity. The goal here is nothing short of a paradigm shift, moving beyond one-size-fits-all treatments to personalized, network-specific interventions that actually fix the underlying problem, not just mask the symptoms. You know, this technology suggests a future where we might not just be treating disorders, but actively optimizing our own mental well-being. And that leaves us with a pretty profound question to think about. What does it mean for us when we can directly interface with, and even fine-tune, the very mechanisms that make us who we are?